This is part 2 of the interpenetration, and I'm going to do the development of the penetrating pipe, or also referred to as the secondary pipe, which will be in this case the square prism that is doing an interpenetration with the half cylinder. So what we need to start with is to draw a light baseline that we're going to use from where we will do our construction. So you can actually draw the baseline anywhere on your paper, wherever you have space. So what I'm going to do is I'm just going to draw a light construction line here at the bottom as a reference, and then also draw a vertical construction line, and then I'll draw a baseline of an indefinite length for the time being, and also a height for the development. And then I'm going to clean all of the guidelines. So now I have an indefinite length for the height of the penetration, as well as an indefinite length for the development of the penetration. Now what we need to do is, because we are using or doing the development of the penetrating pipe or the secondary pipe, we need to know what will be the length of each of the sides of the penetrating pipe, and therefore I'm going to go now to the front view, and I'm going to use the auxiliary view, which is a 90-degree view onto the slanted pipe here, to show us the profile as well as the true length of that penetrating pipe. So let's just measure the distance from number 1 to 2. Because it's a square, all sides will be the same, and in this case the radius is 31 millimeters. So therefore I'm going to go to my development, and I'm going to make the first segment of the penetrating pipe a distance of 31 millimeters on my baseline. And then I'm going to plot a dot to indicate that measurement that I've just made. And I'm also going to draw a light construction line from that point vertically up, also at an indefinite length for the time being. And now I have done the first segment. So what I want to do is first label what I am doing here. So therefore I'm going to start with number 1 right here at the beginning, and I will do number 2 here, because the distance from number 1 to number 2 is 31 millimeters, which is the distance that I found here on the auxiliary view from number 1 to 2. And I'm going to carry on with the segment. So the next thing I'm going to do is just measure again the distance from number 1 to 2, which is 31 millimeters, and I will plot another dot on that segment, and I will continue to do that. I need 4 segments because obviously the square has 4 sides, and then I will just make sure that that distance is in fact 31 millimeters, and plot a dot at each one of those segments. And I can get rid of my measuring tool, and now I can just draw a light construction line vertically up for the height of the development at an indefinite length. We will determine the correct height of each of these points just now, and for the time being I just want to give myself a guidance from which I will work. Okay, and then I can number each one of these. So I'm going to go to this one and give that a number 3, and this one number 4, and the last one back to number 1, because we have a rule when we do developments, what we start with is what we must end with. So if we start with number 1, we know we will also finish with number 1. Good, so there we have more or less a layout of our development, and I'm going to make sure that these lines connect right to there. And I want to now determine the height above each one of these numbers of my penetrating prism, and therefore I'm going to go now to my front view, because at the front view I can see from number 1 to 2 to 3 and back to 4. That's the baseline that I have now developed, and 90 degrees to that I have the height of number 1, number 2, and number 3, as well as number 4, which is in line with number 2, just at the back. But when we unfold it, obviously, we have all the numbers spread out evenly, as we see here, in there, each with the same segment distance. So what I want to do is determine the height now of number 1, and I'm going to go and measure from the base of number 1 to the height where number 1 will be cut off and where the interpenetration happens with the half cylinder. So for number 1, we have now 12.3 as a distance for the height. So I'm going to go to my development and say tab 12.3, and then I can plot that height and get rid of the measuring tool. Now I know that is now the projection of the height of number 1 on my development. Now obviously, because we said the rule says what we start with is what we end with, so I'm going to immediately go and draw a light construction line right across the development to the other side and plot a dot at the height of number 1. And then I know that that will be what we end with, and I label it number 1, and then I can get rid of that construction line. Good, so now I've got number 1 at the start and at the end. Then I'm going to go to number 2, and I want to work with the distance from number 2 all the way to over here to the furthest point where number 2 will penetrate, and that distance is 58.3. Therefore, I'm going to go to number 2 here, and I'm going to say tab 53.8. Let me just double check the height, that it is in fact 58.3. 58.3 is correct. Number 1, just double check. That one was 12.3. Let's just make sure that I have used the right height. 12.3, yes, so far we are correct. So I have the height, and I'm going to plot number 2 there, get rid of the measuring tool, and then I'm also going to label number 2 right up here. And then we just do the same with all the other numbers. So I'm going to go to number 3. The height is 37.6. I'll move to number 3 segments. Tab 36.3. Just double check that height. 37.6, pardon. So let's just fix that. 37.6, sorry. Tab 37.6, and then we plot that dot. It's very important to double check your measurements, because if you make a measurement here, obviously your development will be completely wrong. And then number 4, you're going to measure from there, and that height is exactly at 27.6. Tab 27.6, and we plot the dot. And just to make sure, I'm going to double check that height. 27.6 is what I've measured. 27.6 is right there, and from here 27.6. Perfect. Good. So now we have the major intervals of the development. So I'm going to place number 3 there, number 4 over there, and then I can just shorten these construction lines so that they meet exactly at the dot, because we want to work neat and tidy. I call this housekeeping. Good, so now we have from number 1, 2, 3, and 4 and back to 1. But now we want to determine a proper profile from number 1 to 2 and all the other numbers in sequence. But we can't draw them solid. straight lines, because obviously we know we are working with a half cylinder which has a curved surface. Therefore, there will be a curved profile from one number to the next, and therefore we also need to use these intervals that we have created on our front view from A to B. So I want to now also determine the placement of A, B, and C between these sides of mine. So I know that between number 1 and 2, I will have to go to my front view and see that A and B is lying on that side of number 1 to 2. So if I see here on my top view from number 1 to number 2, I have B and A. So what I want to do is determine the true lengths of A and B onto my auxiliary view, because we also know that another important rule for developments are that we can only do a development using true lengths. So all the lengths that we use from the start to the finish on a development has to be true lengths. So what I'm going to do now is project at that angle of 30 degrees, the angle with which the penetrating pipe will penetrate the cylinder. I'm going to project a light construction line all the way to my auxiliary view for B as well as for A at that angle, and I'm going to draw a light construction line from B to there. Let's just take it all the way through to the other side. Actually, it's only needed to there, and then also I will do the same for A. From A's intersection, we'll draw a light construction line all the way to there, and then I can clear these construction lines. So what we want to do is now take the distance on this auxiliary view. Because we're viewing the auxiliary view at an angle of 90 degrees, we know that the distance that I measure from number 1 to this point, let's label them so that we can use a proper reference. So that will be B over there, because it's the projection of B onto the auxiliary view, and then of A onto the auxiliary view. So now we have point B's true length from number 1 in the direction of segment 2. So from 1 to 2, I have B and A. So I'm going to measure now on my auxiliary view the true length from 1 to B, and that is 9.8 millimeters. Therefore, I'm going to go to my development and say from 1 to 2, that's going to be 9.8 millimeters. And then I can draw a light construction line from that intersection straight up, also again with an indefinite length. And I can clear my measuring tool, and then I do the same now from number 1 to 2 to get A, or if you want to make a shorter measurement from 2 to A in the direction of 1, does not matter, whichever you prefer. So it's 5.7 from 2 to A. So from 2 to A will be 5.7 millimeters. And then I will also draw a light vertical line straight up, indefinite length, and I will clear the measuring tool. And now I can plot my two labels there. So I know this one will be B. That's where I have B. And this one here is where I have A. Okay, let's just place the labels closer to its origin. There we go. So now what I need to do is go back to my front view and measure the distance from the baseline to B's height. The place where B is going to do the interpenetration with the cylinder, and therefore I'm literally just measuring the distance on the height here, because I have determined the true length position of B. Now I have to take the height, which is 19.6 for B. So I'm going to measure from B's here, tab 19.6, and then I plot the position of B there, clear the measuring tool, and then I will also shorten this line to stop right there where B will be, and I am going to number that point B. Now that I have that, I just need to do A as well. So I go back to my front view. I measure from the baseline A to the height of the penetration, and that will be 38.7. So from A is tab 38.7, and then I can place my dot there and clear my measuring tool and label that number there, or that dot, as letter A. Good. And then I will shorten the line. And now I have the two reference points that will give me a clear understanding of what would be the curved profile of that edge from number 1 to 2 as it wrapped around here on my front view where the prism penetrates the cylinder. So there we have that curved profile. Now we need to do the same with the other. So what I want to do is now determine what reference points I need between 2 and 3. So let's just see on our top view we have from 2 to 3, A1 and B1. Now obviously I can't measure these heights here or lengths here on the top view because the prism is slanted here, therefore it does not give me a true length. Although if I were to project these heights or distances over to my auxiliary view onto here, then obviously I could have measured it, but because I'm already busy doing my measurements here on this auxiliary view, I'm just going to carry on to measure from there and take B1, and I didn't have to do C1, so let me just clear C1 to avoid any confusion. I want B1 and A1, that's the two that I want, onto side 2, 3, that's what I want to determine. And I'm going to draw a light construction line from A1 onto side 2, 3 of my auxiliary view, from B1 onto side 2, 3 of my auxiliary view, and then I'm going to clear the construction lines, and then I know that over here I will have A1 and I will have B1 on this intersection here. And now I can measure from 2 to A1 the distance as a true length. From 2 to A1 is 5.5. So I go to my development. Let me just double check that. I think it was 5.5. Yes. So from 2 to A1 was 5.5. And then I immediately go and draw a light construction line that's vertically straight up, indefinite length. And I can immediately go and measure that, or label that as A1. And the next one will be from number 3 to B1. That distance is 9.8. From 3 to 2, or in the direction of 2, 9.8. Excuse me. And then I draw a light construction line, an indefinite length. And now I can go back to my front view and I measure the height. At this point, the construction becomes rather redundant because you just repeat this. So that's 43.4 at A1. Tab 43.4. Let's double check it just to be sure from A1 to A1. 43.4, that's correct. And then from B1 we measure 37 millimeters on the dot. So that's B1, tap 37 millimeters on the dot. Okay, let's just do this proper because there's now a lot of lines. Let's do this clear there, and let's label B1 as well. And shorten the lines to the right height where the point intersects. So now we have the curve that is going to give us the profile from number 2 to 3. Next we want to do from 3 to 4, so we go back to our top view and we see that from 3 to 4 we only have C1 that we need to determine. So we go to our front view and see here is C1. Therefore I'm going to do a projection that is at the angle of 30 degrees from C1 onto the auxiliary view. Draw a light construction line and clear the guidelines, and then immediately go and label that as C1. It's very important to keep your labels close to your projections, because obviously on paper you will see these lines are appearing much closer to one another. And if you do not label them, you will definitely get confused with which line or projection will be which. So please always label as you draw. So what I'm going to do is I'm again going to measure now the true length from 3 in the direction of 2 towards C1, and that's 11.4. So that's from 3 towards 2, and that's going to be I apologize, sorry. I actually needed to measure from 3 to 4, but if you will see here, maybe this is a good thing that I've made this slight oversight. That distance anyways, you will see now, from 3 to C1 that I've measured there is the same on both sides, so 11.4. But let's do it so that it's proper and that you understand there. So from 3 towards C, from 3 towards 4, we have C1 over there, and the measurement is 11.4. Good. It would not really make a difference because obviously the auxiliary view is symmetrical in this case, but just to keep yourself organized, maybe it's best to leave the label where it's supposed to go. So we're going to go now from 3 towards 4, and that's going to be 11.4. And immediately go and draw that vertical construction line. And we know that will be C1 that we have here. And then we just need to get the height of C1, drawing or measuring from the base where C1 is to the penetration, which is 31.7 for the height. So 31.7, and I plot the distance and do some cleanup. And that will be obviously the point for C1. And what we need to do next is just the final point, which will be, if I look at my top view, from 4 towards 1. Now from 4 towards 1 we only have C there at the top view. So if I go back here to my front view, from 4 to 1 we need to take C here. So I'm going to use my guideline, my angular construction tool here on TurboCAD, and then I'm going to draw a light construction line from C all the way, and this time I'll do it right from the start. And I'm going to label for myself now number C right there, and move it a little bit up. Okay, and then I measure that distance from number 1 towards C. That's 11.4 as well. So remember, we measured now from 1 towards 4, and it was 11.4. From 1 towards 4, and that was 11.4. And again, I say you could have measured from 4 towards 1, but then obviously the length would have been just longer, but that's your preference. And then I'm going to go and draw a light construction line vertically up. So the last step is to now just measure the height of C on my front view, and that will be a distance of 15.7. Tab 15.7, and that will give me the position of C. Let's do some clear of that, and let's label C right there. Good. And we will just shorten this construction line to the center. Okay, so now what needs to happen is that I need to label all these other dots that I haven't labeled. So I need to make sure that they are all also properly labeled. Now, some teachers do not require this, but I think it is a good practice just to label the points at the top as well, so that you keep the logic flow of these numbering correct. Okay, so now we have all these points. Now, what I want to do now is just draw the final shape of my profile. So what I'm going to do is first save up to here. And as I said with the previous video, sometimes with the Bezier tool, we find that the TurboCAD sometimes crashes. In this particular version, I'm using version 16 of TurboCAD for this tutorial. But so let's hope it does its job. So from number 1, I want to now go and draw a Bezier tool curved line, and on paper obviously you will use your flexi curve or your French curve to do this, and then you will snap to each one of the center points of your you just go one step back and just stop it there, so finish, and then I'll start again from number 2 to A1. Chronologically I just follow and I plot, and I'm gonna finish it there and snap it to C and then to 4, and I'm drawing this now in solid lines because it's the outline of the curve, and then finish. So now the curve is drawn in solid. All that I need to do is now draw solid as an outline as well, the base and the outer edge of my development. So from number 1 all the way through to number 1, because what we started with is what we end with. And if you worked correctly, you will see here is the full development of the prism. And one last thing that we need to do is, because we have used a square prism, at each segment we obviously will now have a fold, and therefore we will draw a solid line there. Sometimes they draw a fold line there, which means it's a double dash. It looks like a center line but has the double dash line, and I'm just drawing a solid line here because each of my sides of my prism is a straight edge. And there we go. So I've got light construction lines to show my constructions for the points in between number 1, 2, 3, 4 and back to 1. And now we have a perfect and neat development of the penetrating pipe. I hope that you have enjoyed this video. In the next video I will be showing you how to do the development of the round or half cylinder. Thank you very much.